Welcome to Thursday of week 9. Thank you. Just some quick announcement-y things. We're now all done adding stuff to Moodle. So graphing parabolas is our last topic. We'll have time to start that today. Maybe we'll get through it. We'll see. And remember that if you go to the welcome and syllabus at the top, then in the resources on the side, you now have a practice final that you can click on. And I have not heard back from my boss in the past 2 days. I don't know if this is going to get changed much and how closely it can represent the real final for people who take a test in person. But hopefully she will say, yes, this looks great. And then it'll be like this. In any case, the final exam has 2 word problems on it. They're very different. They will help us review different things, and that's a great way to get started today. So I put them on the end of the Tuesday whiteboard because that's the topic they fit in. So we're at the more about exponents on that whiteboard is where I have put these 2. Okay, but for now I will put them in chat so no one has to go. Problem 12 is not the same thing that we did Tuesday. It's the other kind of problem with a system of equations, 2 things with a x and a y. And if we have 2 equations and 2 variables, then we can solve. Usually we solved with the substitution method, but every now and then we could use the elimination method and get rid of a letter by adding up the 2 equations, one on top of the other. So let's just do this and see what happens. So an ice rink sold 38 tickets for the afternoon skating session for a total of $240. I'm not writing anything yet. General admissions, okay, so let G be, now I could let G be the number of general admission tickets or the price. I'm going to keep reading. General admission tickets, they cost $9 each. So G is the number of general admission tickets. And then keep reading. Youth tickets cost $3 each. Oops. You can see my brain lose track of things as I'm trying to write and talk at the same time. Let Y be the number of youth. So how many were sold of each kind? I need to find G and Y. Everyone okay with what I'm doing? You could use X and Y if you wanted. The letters don't matter.
Okay.
Okay, let me put the link in chat again.
Can you say what you said again about doing the problem? I was away for a second with my son.
Okay, so I read the problem and found the 2 things we didn't know. We were told the total number of tickets. We were told how much everything was sold for total. And we're told the price for 1 ticket of each kind. But what we didn't know were how many general admission tickets were sold and how many youth tickets were sold. So those are the things I made up letters for.
Okay.
So I have 2 different equations I'm going to make. One is total tickets. That's a nice simple one. If I add up G and Y, what do I get?
240.
No, that's you know. Look at it carefully. Is the
Oh,
font
total ticket 38.
38? Yeah, there's 38 tickets. So G might be 30 and Y might be 8 or something like that, right? We don't know yet. The second equation I'm going to make is the total cost or total sales, whatever you want to call it. So I have G general admission total, G general admission tickets sold, and each of those brings in how much money? $9. So 9 times G is how much money they brought in that day from general admission. Everyone okay with that?
Yes.
And similarly, the youth tickets were $3 each. So 3 times Y is how much money they brought in from the youth tickets.
And then that should equal 240, right?
Yes, that's what's 240.
Yeah.
So on one hand, this is a little tricky. On the other hand, this is why you have practice finals. This isn't going to change. You're going to always set it up this way. It's not a surprise. So it looks like my next step is to do a substitution type thing. So let's set it up. For substitution, we need to get one of either G or Y all by itself. It doesn't matter. We could do Y equals blah, or we could do G equals blah. Which one do you want?
So do you have to do it for both equations or just one of
No,
them?
just one of them.
Well, I guess we'll do total sales because that seems like the harder one. So,
Now do the easy one. Don't make life harder.
well, if you can do the hard one, then you can do the easy one in
No,
theory.
we're going to use this in the other one.
Okay, well then we should take away y from both sides of the total tickets equation.
Okay.
So it'll make it 38 or negative y plus 38 or g equals negative y plus 38.
Yep, I'm writing it as 38 minus Y, but yes, perfect. So now that we have G equals blah, wherever we see a G, we can put blah. Okay? So now we have 9 times
Oh, okay.
Y. Is this ringing a bell? It's been a few weeks.
Yeah, no, I get it now. This is why the easier one was better to do first.
This is why the easy one was better to do, right? Now I'm going to distribute. So 9 times 38, what's that? Let me get my calculator. Back when I just went on. Okay,
342.
342, you are faster than me. Okay, whoops, 342. Minus Y times 9 is minus 9Y plus 3Y equals 240. So 342. You could do this in fewer steps, but since a lot of people are absent today, I'm going to do this in lots of steps. So negative 9 plus 3 is missing 6Y. I owe somebody $9. I get a paycheck for 3. I can pay off 3 of the debt. Now I'm in debt 6.
Oh, I see.
And I'm going to
Then are
add
you
6Y to both sides because I don't like having a negative letter if I can avoid it. And then I take away 240 from both sides. And again, you could do this in many fewer steps if you wanted to do more than one thing in a step. But I am being as meticulous as possible.
That's
since
great.
Being recorded.
So the 102 equals 6y.
Yes. And I can just stare at 102 and know that it's divisible by 6. Because it's even and the digits add up to 3. Remember all those little rules we learned. So y is
17.
17. Now, what was y? This is why I made that little note at the top. If you don't make this note at the top, then what happens often is you will just put y is 17, put a box around it, move on, and get only half credit because you didn't answer the problem well, even though you did 99% of the work. So this goes up at the top, but y be the number of youth tickets? So that reminds me, so 17 is how many youth tickets there were. And if it adds up to 38, that means there must have been 11 general tickets.
And then that's the well, that's the see, I was overthinking it. I was like, okay, now we're gonna plug y into the original equation. But no,
Oh,
you could just
we just
subtract.
picked the easy one.
Right.
To get that 11, I had to go up and use one of these two equations. Either this one or this one. So I'm gonna pick the easy one. They add up to 38. So there we go. That's a great kind of thing to be able to do. I'm not sure if you'll ever have to do it on the job, but you can't run away saying, when will I ever use this in real life? Right now you've seen an example. Much
Nope,
less
I like it.
practical is shooting things up in the air, but we can do that one too. But first, any other questions on this one?
Not for me, but
link to
got
Miro
a
in
couple
our
people
chat
jumping
again.
in.
Yep. People are continuing. Okay, so Dusty Pasumsuk, we did a little bit of talking to start with in the more about exponents Jamboard. So the same Jamboard where we had pictures of archery and a coin flip at the end of Tuesday, we're putting 2 more example problems. These are nice example problems to do because we stole them right from our practice final about an ice rink and a roller coaster ride. So we're at the bottom of last class's Jamboard doing more word problems. The word problem we just did was not one with an x squared in it. So it was the 2 equations, 2 unknowns style of word problems from a couple weeks ago. But the one here will be the kind of thing we did Tuesday. So if you just joined us, you didn't miss review of Tuesday, you missed review of a week ago or a week and a half ago.
Okay.
Is this big enough to read? Can everyone read the at the peak of a roller coaster ride?
Yeah.
Yes, okay. So at the peak of a roller coaster ride, I'm going to make everyone cringe and draw a little picture. So there's my roller coaster ride. A rider's sunglasses fall off her head. Okay, so she's sitting there and her sunglasses fall off her head and fall down like that. Okay. The height after she loses them is given by a formula there. I'll write it so it looks a little more legible. H equals negative 3t squared plus 30t plus 14. And remember my habit, whenever I am told one of these, I don't trust the person who gives it to me. Is this really a sensible thing to do? I'm going to plug in t equals 0 and see if it makes sense, because it's really easy to do. So if I put in t equals 0, negative 3 times 0 times 0, that's going to go away. And 30 times 0, so I have a height of 14. So at the beginning, her glasses are only 14 feet up off the air. This isn't a very big roller coaster. Everyone okay with my thinking so far?
Yeah, I had to take care of something real quick, and I just missed the last 5 minutes.
Okay, so I drew a little picture because I like pictures. And whenever someone gives me an equation like this, then I like to plug in t equals 0. Because that tells me when the clock starts, t is time, how high are we up? If you look at the
Gotcha.
recording before, we did that with the arrow and the archery and the coin flip.
Right.
So if I put in t equals 0 this time, those two terms with t go away, because multiplying by 0 means there's 0, and the height to start out is 14. So this isn't a giant roller coaster, right? This is almost a kiddie-sized roller coaster, 14 feet up. The glasses get
Gotcha.
bigger. If I put in t equals 1, then I'm going to get a minus 3 in this first term, but I'm going to get a plus 30 as well. So she's like going upwards when her glasses fall off, and they keep going up even as the roller coaster pulls her down. So I've tried to make that true here, drawing the picture so it goes up a little before it goes down. Okay, how many
Okay.
seconds later will the glasses hit the ground? So how high are the glasses when they hit the ground?
Well, when the glasses hit the ground, they're at 0.
Yeah, so we want to solve this equation when the height is 0. Right, smash, there we go. Everyone okay so far?
Yes.
Yeah.
Okay, so just again, as a contrast, if you were here the last 10 minutes, notice how different this is. Right, we're totally different word problems, but I'm not gonna go into that more. Okay. So what am I trying to say again now? That 0 is my height. And that's negative 3t squared plus 30t plus 14. Is there some number that I can factor out of the front? Does 3 go into everything? No, the 14 ruins it. Are they all even? No, the 3 ruins it. So I'm just kind of there. So I could do this with factor by grouping. Can I find two numbers that multiply to be 3 times 14, so the negative 42, and add up to 30? Maybe. Or I could just give up and run away and go straight to the quadratic formula, which isn't quick, but I don't have to like try something and decide it's not going to work. Because we're doing a review, let's do both. Let's have some hope. Maybe we can just factor this one and solve it that way. And if we do, I'll still do it with the quadratic formula version. And if we get stuck, that's fine. We'll still just have reviewed the factoring. So the format again that we are saying all of this stuff is ax squared plus bx plus c make that look a little bit more like a squared and not something droopy. So my A and my B and my C, my A is -3, my B is 30, my C is 14. Everyone happy so far?
Yes.
I'm writing again more than I need to. If you've done a bunch of these and you're on a roll, you can just look at it and say, oh, A is -3, B is 30, C is 14. But you know, it doesn't hurt to be slow and careful if you're not on a roll. So the factor by grouping started out by imagining a box. And my box had a length and a width. The area was A times C. But then when you, actually, let me do a different color for that. It's A times C for the area. But also when you added them up, if you went this far, that looked like a plus. You went that far, and then you also went that far, then that total distance was B. Does that ring a bell from before?
Yep.
So I want two numbers. That multiply. A times C is 3 times -14, so -42. Oh, God. And when they add up, it's 30. So I'm just gonna start making a list. Well, 1 times 42. Is that gonna do anything nice? No. 2 times 21. Is that gonna do anything nice? No, that doesn't get me to 30. 3 times what? We just did that up above. 3 times 14. Doesn't add to 40. Does 42 go into, does 4 go into 42? No, because this 21 is odd. 5, no. 6, sure, 6 times 7 is 42. Does that add up to 30? And now we've gotten back. If there was something 7 or more, it would have to show up on this side with a smaller thing over on this side, so we could stop. Those are all the factors of 42. None of them add up, no matter which ones I make positive or negative. So, oh well, we tried the factoring, it didn't work.
Gotcha.
So now let's grab the quadratic formula. So there it is. I'll also grab my A, B, and C. Oops, come on, click on it. Oh, I lost some. Okay, ready to start plugging things in?
Sure.
This isn't scary because the calculator is going to do all the work. We just have to set things up without making any careless mistakes. So -B, -30. Then it could be plus or it could be minus. Either one works. I'm going to write them together because that's easier. B squared minus 4AC. So that's the square minus plus or minus the square root. B squared, 30 times 30 is 900. 3 times 3 is 9 with 2 zeros. Minus 4 times A times C. So 4 times 3 times 14. gives me 168. All of that over twice A, so -6. Did I plug everything in correctly?
Looks like it.
Okay, where am I going to make mistakes if I make careless mistakes? Where do students get these wrong?
Minus.
Yeah, the plus and the minus stuff. Right?
Wait. That means you have to do it twice, right?
So if B has a negative sign in front of it, right? So a very common mistake is if B itself is negative, you don't make it plus. You forget that the minus.
Oh.
This minus messes people up. If A and C, well, in fact, it messed me up. You didn't catch it. Shame on you. A times C is a negative number times a positive number, so that's negative. When we subtract it, it should be getting positive. And the 2A less so, but 2 times a negative number is negative. So it's the positive and negatives that will mess us up, as you just saw, and make you get the wrong thing on the GED test. So be careful of positives and negatives. Now that you got it, it's the calculator's problem. So -30. I'll start with plus the square root. Actually, I'm going to do another line. So 900 minus 168. No, plus 168. And 68. Okay, so that's what I'll put in here. And 68. And then I think I have to put that in parentheses. So everything is divided by -6. Did I do that right? -30, -6, looks good. Okay. So there's one of our answers. Actually, I'll paste them both at the same time. I get a -0.44, blah, 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 blah. That looks very suspicious. Let's do it again, but where it's plus or minus, now we'll change it to minus. And I get a positive number. So let's paste both of these into the whiteboard and talk about them. Okay, so which one makes sense in this situation?
The positive one.
The positive one, right? So at T is about, I'll do about equal sign because I'm rounding, about 10.4 seconds, the glasses hit the ground. As a side note, the practice final we stole this from randomly generates these numbers. They're not always going to be realistic.
Gotcha.
The negative one, let's go back to our picture, says that, well, if we go backwards in time, there's another place where we're going to hit the ground, right? Not only at positive 10.4, but also at negative 0.4, whatever it was, right? So it's seeing both of these places where the curve hits the ground. Only one of them makes sense in the situation, but you can kind of see in the picture why the math thinks there's two answers. Questions about this one?
No.
No. I think she had springs in her glasses. She was only 14 feet up in the air. Her glasses fly off at this incredible speed, and it takes them 10 seconds to land. Maybe a drone is carrying them or something, I'm not sure.
She's got helium in her lenses.
Yeah,
Too.
okay, but that's what we get with randomly generated. Okay, you want me to do more of these?
I could use another one.
Okay. Can't factor. Let me make a note just for completion's sake. Can't factor, give up. Why couldn't we factor? Because the answers we got weren't whole numbers. Go back on there. Okay, let's do another one. I assume you want to do another of these roller coaster ones.
Sure.
So if I just, oh, I have to sign in to change it. I have to get my other. I have to spell my own name correctly. Okay. It's not me, it's the keyboard. Okay, yeah. Okay, so now if I go down, if you save your own copy of this, which I guess I could have done, but then I'd have to log in anyway to LCC. If you just change anywhere, anything, all the numbers change. Okay. Oh, just because I'm recording, remember there's an answer key at the bottom too. But if you are taking a test, print out the answer key also, otherwise, when you load this up again, it's going to change on you. And you will not have the answers you're looking for. Okay, I'm just going to do this one, if it's okay with you, only with the quadratic equation. Show you kind of a more realistic, if I was taking the GED, how I could do this and how much time it would take. Sound good?
Yep.
So writing a more realistic amount, I read the thing. If I plug in t equals 0, she's only 8 feet off the ground because these turn into 0. So again, this isn't the most realistic set of randomly generated numbers, but that's okay. What is my A? What is my B? What is my C? My A is -5, that's on the t squared. My B is my 20 on the plane t, and my C is 8. So I write this out because again, this is where I'm going to make mistakes, especially with negative signs. So let's get it nice on the paper before I try and put it in the calculator. So negative B, -20, plus or minus the square root of B squared, 20 times 20 is 400, minus, but A times C is going to be negative. So that's going to turn into a plus. This is where we messed up last time. 4 times A is 20 times C is 160. All of that over twice A, so -10. Okay, did I do it right this time?
At the -20. Isn't it supposed to be 400 negative 160?
But the A itself had a minus sign, so
Oh,
that
right.
minus sign and this minus sign become a positive.
Well, it
Then
throws me off because it's 4 times A times C.
C, right? So 4 times -5 times 8 is going to be a -160, and then when I subtract that, it becomes a positive 160.
Oh, okay. All right. And -5 times 2, -10. Yep, nope, looks good.
Okay, so it feels strange that looks like a scary problem, but the hard part is this step of writing that carefully. Because now it's the calculator's problem. So here we go. If no one has told you on the GED, you have to use a certain kind of calculator. So practice this kind of thing with that calculator. Don't show up tomorrow morning and you've never used their calculator and you're trying to do something that's a little complicated with square roots and so on. Okay, how do we change it? -20. And 400 plus 160 is 560. And -10. So that's one answer. Or I could change the minus to a plus and get another answer. As before, one of these is positive and one of these is negative. Because if I sort of rewound a video recording of her glasses flying, then that would make a path that, if they weren't on her, would hit the ground, before we started the camera. So this one is not realistic in real life. This one is the positive one, that's the one we want. Six is 5 or more, so we'll round up on the 3 and make it 4.4. Remember, the general rule of rounding is start with the number of decimal points the problem had or one more. So the problem doesn't have any decimal points in this. It's not like 20.0t plus 8.0 and 5.0. So I could just round it to 4, but I'll be a little more specific and say it's closer to 4.5 than 4 seconds. You want to try one on your own and then we'll compare answers?
Yeah, that sounds good.
Okay, so I will change some numbers again. I think that C should be higher. Since I have special powers, let's do that. What is C? Ah, I see what I did. If I make C realistically large, then you'll never be able to factor it. And this is always going to be a quadratic formula 1. So that's why I did it that way. I think that's an okay decision. We can have helium glasses. Okay, so here is your problem. I'm just going to copy it in bigger letters. So if someone is watching this video on their phone, maybe they can actually read it. The height is negative 2t squared plus 28t plus 13. I'm going to pause the video recording. So if you're watching at home, try this on your own and then unpause, and then we'll have it together. So if you are looking at this board later, hopefully someone has put the brown paper reveal your answer back, but here we go. Ta-da! So the positive answer I got is about 14.4 seconds. Maybe I did this right. Notice I didn't try to find everything. I just typed into the calculator negative b 28 minus the square root of, I didn't square b ahead of time. I just put 28 squared because the calculator can handle that. Minus 4 times a and negative 2. I just put the negative right in there. And 13 over 2 times a, that time, that I could have put 2 times negative 2, but I did that one. So but you can take things out in the calculator more without condensing them ahead of time, if that's your style. Did everyone else get 14.4? 14 point, did I do this correctly?
I accidentally left out my 28 squared.
Ah,
I
So,
I were different. I'm not sure. I were the different thing, teacher.
okay, I'm gonna cover this back up, and then if somebody watches later, they can be surprised also. While we were paused, I had a nice idea and changed it from glasses to a paper airplane. So if it takes 14 seconds to hit the ground, we can now imagine that it's slightly more realistic than helium-filled glasses. Okay, so that's the end of this topic. Right now we have done everything in the more about exponents topic. Remember, there are lots of videos, including just about using the quadratic formula. The whiteboard we were just at is linked here. Your homework has some quadratic, they call it quadratic equation instead of quadratic formula sometimes, but that's okay. In future weeks, we'll do our group work quiz, give us more problems to work on together. In future weeks, we can have the discussion forum and talk about preparing for a math test, but we'll save those parts. You are welcome to do them early though, if you want your nice progress bar to get more green, right? Click that, and when I reload, I have some green, yay. Remember, these ones you can mark as done whenever they are as done as you will get. That does bring me to a tangential comment of, I had mentioned a few weeks ago that math doesn't work like the Matrix movie. I would love it if I could just like plug something into you and you know all of this, but you have to do the homework to learn it. Watching me doesn't actually do anything. It does something for a very short time, but watching me is just like a little boost to get you able to do the homework comfortably. So if you are really busy this term and aren't having time to do homework, I'm glad you're here. It is certainly better than not being here. Maybe you're happy and eating dinner anyway. But if you're saying this is the winter term and it's better than nothing, but I'll really take math E seriously in spring term, then it's not going to work any better spring term if you're also not doing homework. So just not a scolding, but a heads up that watching me unfortunately doesn't help you as much as you and me both would like it to. Do some homework, if not now, eventually. Okay, last topic is graphing parabolas. This looks like it's as big as all the others, but it's really small and short. And we're going to start by going to this Desmos graphing calculator, which I will put in the chat for you. Did that actually work? It made a clicky link instead of a URL. Somebody tell me if they can click in the Zoom chat and get to this page or not.
It works.
It works, okay. So I'm going to want to see you do this. Normally, I can trust that if you're following along, that's enough, but this is such a important conceptual thing that I'm gonna, in a moment, stop sharing my screen and ask you to share yours. We'll take turns doing things. So heads up about that. But for now, once you get this page, then type in y equals x, and you want y equals x squared. To get the squared, you're going to do shift 6, that little mountain shaped thing. It's called a caret symbol. And the website knows that you want an exponent, not actually a little caret mountain symbol. And that's how you can type y equals x squared. So have that for now. And I'm going to move to our other Jamboard, not Jamboard, whiteboard, and put that in the chat also.
Anna says she needs to put a kid to bed.
Yeah. It is 7.
How did you punch in squared?
How did I did let me write it, shift 6. Which looks like that. So y equals
Okay.
x, and then that thing, and then a 2.
Got it.
And if you look at some calculators, if you try and do squared on a calculator, a physical one, it's the same thing. Okay, I wanted everyone to do this, and then yes, it is time for a break, but I wanted to be able to do some tech support if people couldn't get this working during break. As a side note, if you are using Microsoft Edge, there should be a way to split the screen. Here we go. I'm gonna put this and this side. You don't have to do this, but there we go.
The Desmos calculator is also available on an app on your phone.
Ah, good to know. Okay. So if you are good, if in 1 or 2 windows, 1 or 2 tabs, you can see what is on the screen, enjoy your break. If you need some tech support, holler, and I will stay here and not stretch my legs. I'm gonna pause the recording. Okay, now we're gonna try something that's not tricky, but it's kind of conceptual. I'm trying to get you in your brain to understand what a parabola is and how it behaves. So, as it says in this box, lines are very familiar. If I have a line, then there's really not much I can do with it. I can shift them on the graph in 2 ways. I can move the line up and down, or I could aim it in different directions. And aiming it adjusts the slope. If I had y equals x, there's my line. And if I made it y equals 2x, it gets steeper. And if I made it y as 1/2 x, it gets shallower. Or I could make it go up, like +4 moves the y-intercept up 4. And if I have y equals x plus 4 and y equals x plus 5, then, come on, you can see that moving up and moving sideways is the same with lines. So lines make sense. They're straight things. We have rulers and straight sticks and things in real life. We can aim them. We can move them up and down. That's all we have to worry about. But parabolas, we don't tend to see very much. They appear all the time in real life. Whenever you have something like that arrow or trajectories in the air, but those tend to be invisible when we can't see them because it's the path something makes in the air. So we don't have a good intuition about parabolas just from growing up and smacking our siblings with sticks. So now I'm trying to give that to you. So I'm going to go through a series of questions here on the whiteboard and ask somebody to show me what happens. I'll stop sharing my screen and have you share your screen. And the first question is, what does making the x squared term negative do? And I think just to be fair, what I will do is make a text box and put everyone's name just in the order you're on my screen. Oh, I see, it's just wrapping around, okay. And I'll erase your name when you've had your turn, so everyone can take a turn and I don't have to keep my brain on. So the first question is, what happens if we put a negative sign in front of the x squared? So I'll stop my sharing. Who wants to share their screen and show us that?
All right, I
So
will share.
are we sharing our screen and just putting in?
Putting in a
Uh,
negative sign.
Okay.
Trying to share, but entire screen. It only gives me the option to hit cancel. It's not. It's like the share button is grayed out.
Share button.
Yeah, I click on share. It says what to choose what to share with the Zoom.us app. And it says I can do the Chrome tab, the window, or the entire screen. So whether I do either one of those. At the bottom, it has a share and a cancel, but the share button is.
Okay, someone else try. I have heard other reports of Chrome and Zoom not playing nice together.
Okay. I also have Chrome, but
Chromebooks don't play nice in Zoom sometimes. Okay, there's Dusty. He has a wonderful picture. Put a minus sign in front.
put a minus sign in front of the X.
Yep, in front of the X. What happens?
It's moved everything from the positive spectrum to the negative.
Yeah, does it make sense if all the numbers that used to be positive are negative, that now it's upside down?
Yeah.
Yeah, and if you noticed, all the ones we did as word problems with arrows or coin flips or glasses or paper airplanes, they all had a negative in the x in the t squared thing, because that's this shape of it goes up and then it goes down. So if the x squared, if the t squared, right, any letter squared, if that's positive, you're looking at a bowl. And if it's negative, you're looking at a mountain, or however you want to imagine it in your brain. Everyone good so far?
Yeah.
Okay,
Yeah.
so great job. Stop sharing. I will erase Dusty's name from the list. He has paid his dues. Okay, the next question is, if we put a +5 at the end, so we get y equals x squared plus 5, what does that do? Or also change it to a -5.
Oh,
So
I
who wants
figured
to
it out.
try and show me that one? You got it
I
working.
got it. Yeah.
Okay, so
Okay,
go back
so
to positive. Yep, now put a +5 at the end.
+5 squared, or just, yeah.
Not a 5 before the x. That's a totally different thing. Okay, yep. You'll have to like arrow key past the squared.
Oh, I see.
There you go. So what did it do?
It intersected the peak of, or the bottom peak of the bowl at +5.
Yeah, we just lifted the bowl up in the air 5 spots. Does that make sense? Any number you had before, now we added 5 to it?
Yeah.
Yeah.
What if he puts a -5 instead? What's going to happen?
They'll go
No,
down
but now it
into
has,
the negatives.
Goes down. Okay, are we all happy so far?
yep.
Okay, wonderful. So you can stop sharing.
How do I stop sharing? Let's see.
I can do it for you too, if you need me to. You got it,
Stop.
okay. So I'll take Anthony's name off the to-do list.
He's sharing.
Yeah, he's still screen sharing. Let me find my,
Okay.
oh, we got it, okay. So now we are on the third kind of shift. What happens if I take away my x and instead put parentheses x plus 3? Or if instead of the x I have parentheses x minus 3. So Anthony's done. So Victoria, Kayla, or Pasumsuk, try sharing your screen and change the x in y equals x squared to x minus 3. Or x plus 3. Oh, I need to stop sharing so you can share.
I have the graph open, but I'm not sure how to share it. But I'm also trying to put my son to bed.
Okay,
I'm mostly just
do you want
listening.
me to share? What? Do you want to just talk about it on my screen? I can do that so you can stop clicking. Okay, so we took the x and where the x was, we will put x plus 3. And what happened to my shape?
Sorry, what was the question?
What happened to the shape when I changed it from a plain x to an x plus 3?
Oh, it moved. It moved to the negatives.
Yeah, it slid sideways, right? Let me show you again. There's plane. There's the 3. Why would it do that?
Does it move down the x-axis?
Yeah, does that make sense? If I put in
I don't.
x, like I have to put in -3 to get where I used to be at 0. And I have to put in -4 to get where I used to be at 1. And so on. Or -2 to get where I used to be at 1. So I have to put in different numbers to get out the same thing. So if I want to be at the bottom at 0, instead of plugging in 0, now I have to put in -3. So everything shifts to the left 3. What's going to happen if I change it to x minus 3? All of that squared.
It'll mirror. It'll become a mountain.
That was a negative in front of x squared. I could do that. but that's a
Oh,
different thing.
then I
That's-
don't know.
That's a negative in front of the thing that's being squared. This is a negative inside the thing that's being squared. Well, if +3 made it go to the left, minus
Oh,
3
it'll go to the right.
go to the right.
Okay.
So whatever number I put in before, now if I want it to be at 0, I have to put in 3. I have to put in 3 bigger than plane. Right, there's plane. I have to put in 3 bigger to make anything happen. So it goes to the right. If you're not used to this, if you have a plus, you want it instinctively to go to the plus side of the number line, but it moves to the minus side.
Oh, that's
So-
annoying.
Minus, you want it to seem like it goes in the minus side of the number line, but it's on the plus side. So just stick in your brain very firmly that this is backwards.
Does that have 2 points? What is Y?
Is it on 2 what?
It has 2 points with just that one. Is that Y equals or?
Yeah,
um,
y equals parentheses x minus 3 close parentheses squared. And as we mentioned before, we can combine this with other things. If we make a negative sign in front, it flips it over. If we add 5, it lifts it up in the air 5. If we put a negative sign in front now, it flips it over. Make sense how we can change things a bit?
Yeah.
Yeah.
Okay, so that was Victoria calling out while I did stuff. Kayla, are you back yet? No, okay, so presume so either tell me you want to share or talk and I will do the thing. Or on our last one, if I put a number in front of the x squared, what will that do? You want to try sharing?
Yeah, I can. But
Okay,
I will
share.
only share, but share my screen.
Yeah,
Let me see. Okay. So,
so if you
the
change it
question.
from, yeah, if you change it from y equals x squared to y equals like 5x squared, what does that do?
In front of
Let's see, why don't you get rid of the top two, start with just a plain x squared. Can you hide those or delete them?
okay.
That's fine, and then just make it 5x squared. Or change the 3 to a 0, because that's the same thing. Okay, so there's the plane y equals x squared, and if she puts a 5 in front, what's going to happen?
Y intercept.
Yeah, it
So,
squishes
I-
together. Everything shoots up 5 times as fast, so you get to outer space much sooner. What if she puts in front of the x squared term a 0.5? It's flatter, right? Everything goes up half as fast. Notice it's also changing the scale from 1 to so on.
Oh,
Okay, great. So stop sharing your screen. I want to do a little bit of that together.
can you cancel out? My computer is
Oh, okay. I
If you
will just,
click on the screen share
Yeah.
at the bottom a second time, it'll undo it.
I got it.
Okay.
Okay. So let me do it again here. So if we had 5x², and there's with the 5. There's normal. With the 5, it just goes up 5 times as fast. Or if I did it 0.5, it goes up half as fast. Compared to normal. So all of these we can combine together. It's a little intimidating if you're new to it, because lines, again, we only have 2 things. You aim them differently with the slope, and you move them up and down with the y-intercept. But with parabolas, we have 4 different ways to adjust them. So let me make notes again, because notes are good. What happened when we made the x² term at negative, and that made things go upside down. What did adding a +5 or -5 at the end do? That made it slide up and down. If you changed x to x +3 or x -3, that made it slide left and right. And a number in front of the x² term, that made it skinny or fat. And I encourage you, sometime in the next 24 hours, do this again on your own. Play with it and say, look, there's the plain x² term. I can flip it over. I can lift it up in the air by 10. I can make it skinnier. I can change the x to an x -4 and slide it sideways. And sort of build up some intuition for this. Because ideally, if you see an equation like this on the test, you can just look at it and get some sense of it. Just like I was testing the ones in the word problems by plugging in x = 0. You could say, oh, this is a parabola. And it's upside down. It's a little bit skinny. It shifted sideways by 4 and up by 10. Do you see how I can just read that off the equation? So for now, that's new and strange, but your goal is to make it kind of more second nature. Okay, in green, 2 quick trick questions. How many y-intercepts will a parabola have?
Isn't it only 1?
1.
It's 1. It's always 1, yes. Doesn't matter how I move this or how I flip it. It's always going to cross the y-axis somewhere. How many x-intercepts will it have?
1.
Now, can it have like a maximum of 3 or something like that?
It
Or
could
no,
have
I'm sorry,
1.
2.
If
2.
it had 1, it would look like plain y = x², right? It could have 2. If I shift
Sorry, I
it,
meant this.
now it crosses the x-axis twice, right?
Yeah.
It can't have 3 because it doesn't wiggle and come down again.
No,
But
I
it can
I meant
have,
to say 2. I said 3 because I was thinking of the y-axis.
but it can have 0. If I change my -4 to a +4, it might just be above the x-axis the whole time.
Hmm.
So in our word problems, most of the time, we have seen this case with 2 solutions, right? These points where it crossed a line, like it hit the ground or it was 5 feet up in the air, whatever we were asked That's what we normally see. But sometimes there's only one solution. And sometimes when you do the quadratic equation, if the b squared minus 4ac is negative, you can't take the square root of a negative number. That's the sign that it never crosses the x-axis. It's all just floating above, or maybe it's one that floats below. That could happen also. Okay, the blue question. All the parabolas we care about are like bowls. They open up or down. And that's because in real life, we use these for situations that have either a minimum or situations that have a maximum, and usually you want to find the maximum. So we're gonna multiply two things together. One is how much something costs, and the other is how many of them we produce. And we want to find that sweet spot where we get the most money, because we're not producing too many, and so on like that. Does that make sense? These are good for finding like when's the best we can do, or where's the most stable bottom element. Things like that. If we did want the bowl to open sideways though, could we do that? Is there some way to make this point sideways instead of up and down?
I don't think so.
Yeah, there's one more thing we can do that we haven't yet. You should know this.
I can do one in the spot.
If we take the x and the y and switch them, so whatever the x is doing, the y is now doing. Right, now it goes that way. And again, if you put it negative, then it goes the other way. So if you swap the x and the y, now it's a sideways bowl. But that's not really useful in real life. So we always have the y and then x or time or something like that. But just for completeness' sake, you should know that if you did ever want to turn a graph sideways, you switch the y and the x. You have two new terms, this black line here. The line of symmetry, well, that's pretty obvious. That's the reflection line, right? It goes up and down from the bottom point or the top point. And this little bottom or top point is called the vertex. That's either the most or the least it ever is, based on if it's upside down or right side up. So usually we like word problems finding the vertex. What's the most money we'll earn? What's the slowest it goes when the vehicle travels? That kind of thing. Okay, now I'm going to sketch a parabola, and you're going to tell me its equation. Oh, come on, I want to copy that. Copy and paste, come on. Okay, boom. And we're almost done, but not quite. Okay. So if I say here is a parabola, and its vertex is right here. Oh no, let's do it right here. So at the point
Kevin sent me this idea for first sliver deck that has
over 10
strategy and doesn't do anything for
up
5 turns
4.
and then wins, I think.
And it somehow goes down like that. Don't trust that I'm drawing this very carefully. So what parabola do I have?
Only thing
So
we care
first
about
tell
for
me
all is cascade. You just go land, 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 land. Yes, the first sliver.
Um,
The only card in the
actually,
entire
one moment, I
deck
need
that
to tell you
costs
if
less
it's
than 5
skinny
is
or
Sybil's
fat.
Trickery, so you're guaranteed to hit it, which will then exile cards until you hit your next spell. And then the rest of the deck is filled with cards like Apex Devastator, so maybe you hit that and then Cascade 4 more times. Or maybe you hit a Tully and then
So
get
it
everybody
starts
else's
out by
decks going,
going
including your
1
own, which is
and
maybe
then
Apex
2.
Devastator. Or maybe it's a Virgin Ultimatum and you just pick Apex Devastator.
Okay,
as
so
the
is this
end.
parabola a minus or a plus for before the x squared?
Twice and went your money forwards. We still haven't figured out the
Mm,
exact build for this, so like, subscribe, and then comment if you should be in it.
Dusty, okay. Do I start
Okay, I
with a
can hear
plus
you
or,
very well. What was that you just said?
am I starting with a plus or a minus for this parabola?
Minus.
Minus, it's an upside down bowl, it's a mountain, not a bowl. Okay, it's not just a plain x squared. It's an x that shifted sideways. Is it an x plus something or an x minus something? Since we shifted it to the right. Play around on your Desmos graph. It helps you remember which way goes which. So I'm gonna put a plus or a minus next.
minus.
Minus, yeah, remember it's the other side of the number line from what you might think at first. So minus 10 is going to shift it to the right by 10. And now I want to make it go up 4, so how do I do that?
Patch.
Plus 4 at the end.
Yeah.
And the last thing is, do I need some number in front of the parentheses here to make it more skinny or fat? And I tried to draw it so it was plain with no number there. Any questions on how to do that? This part is iffy. That's the one that's hard to know exactly what should go there by looking at the graph. But this number and this number come right from there. And the plus or minus is just if it's right side up or upside down. Okay, I am going to close that. And whoop, did it make my mural go away also? There we go, okay. So what might you be asked to do with parabolas? You could graph them by using points. Let's just plug in some points. X is 0, X is 1, X is -1, and make a picture that way. We can give you an equation, and then you make the graph from that equation. Or we could give you what's called a vertex form, which is what we've just been playing with, where you have the sideways shift, the up and down shift, and the positive negative skinny fat factor. So when I see you next week, we'll do more examples of this. Your textbook does a pretty good job describing all of that stuff. Graphing parabolas. Look, we can plug in some X's and get some Y's and then just plot the points. Nothing too exciting there. Or if you gave me an equation, I could do the same thing. Let's plug in some X's and let's plug in some Y's and we'll graph it that way. Or you can think about things with the other format. They don't really show you that, do they? They have it here. So, yeah, horizontally, things like that. So they're talking about that. We have time for just one. Is it okay if I skip starting with a table and give us an equation? And we'll make our table from the equation, then we get to kind of do both of these. No one's talking. We could just stop 5 minutes early if you've all fallen asleep.
Just listen, teacher.
See, does it say graph something? Oops, say graph something. Thought there was a graph. Yeah, graph the parabola. Okay, so let's grab this one. Actually, I will do all of the steps. Whoops, vertex. There we go. Okay. Too big, too big. So let's just make some points. If we say. If we plug in 0, well, that term goes away, that term goes away, and we get 5. If we put 1, 1 plus 6 plus 5, 12. If we put in -1, -1 times -1 is +1. -6 brings us down to -5, +5 brings us back up to 0. What if I put in 2? 2 times 2 is 4, +6 is 10. No, +12 is 14, +5 is 19. And if I put in -2, that's -2 times -2 is +4. -12 brings me down to -8, +5 is -3. So I can graph all of these and see what I get. So 0, 5, 1, 2, 3, 4, 5. 1, 12, 5, 6, 7, 8, 9, 10. I have to go up a little higher. -1, 0. 2, 19, that's way up in space. -2, -3. So my parabola is like this, and I'm still not sure kind of where the bottom is. Let's plug in like -4. -4 times itself is positive.
-5.
Hmm?
-5 and oh my internet. -5 and 0. 5.
Yes, -5 is 0. 1, 2, 3, 4, so 5 is 0. -4 would be 16 minus 24. So -8 plus 5, that's another -3. So there we go. So it looks like, whoops, that's -1. So it looks like I was doing it right.
Yeah.
And so on. So no one will grade you on your artwork. Don't grade me on my artwork, but there we go. You plug in points and then you can graph it. That's another task to practice, not terribly hard. Get points on homework, be happy. Okay, I'll stop the recording. You can ask me lots of questions.